on inclusive events and finding the probability of those. So here is the definition of inclusive. It is the opposite of mutually exclusive. Mutually exclusive means two events that are not in common. For it to be inclusive means events that have one or more outcomes in common. One or more outcomes in common. So for example, when you roll a number cube, outcomes rolling an even and rolling a prime number are not mutually exclusive because the number 2 is both prime and even. So we have a picture here of a Venn diagram. You'll notice the red circle represents events where they're even on a number dice. And then event B, or in the blue here, is prime numbers of rolling a dice. And there's one number that overlaps, the number 2. That is the intersection, it's and. So we have to take out, when we do probability, we have to take out this overlap here when we deal with these problems. So here are a couple examples. Oh, we have to get to, here's an example again of rolling that dice. The formula you're going to use, make sure you write that down, of the probability of A or B for inclusive events, events that have something in common. You take the probability of A plus the probability of B, and then you remove the overlap, the one that's intersected in a Venn diagram. To remove the overlap. So example, for the probability of an even is 3 out of 6. The probability of a prime was 3 out of 6. And you're subtracting out that intersection. So you have a 5 out of 6 chance of getting an even or a prime number. All right, so let's go ahead and do another example of a number cube. What is the probability of rolling a 4 or an even number? So let's talk about probability of 4. So we have a 1 in 6 chance of rolling a 4. Now probability of an even number. The even numbers are 2, 4, and 6. So you have a 3 out of 6 chance that it is a even number. And the probability that is a 4 and an even number, you have a 1 in 6 chance. Oops, this should be a 1 out of 4, or 1 out of 6, not a 4. All right, so we're set to go. So we're going to go ahead and sub it into this formula right here. So the probability of a 4 or an even, we're going to take the probability of A, rolling a 4, plus the probability of B, rolling an even number, and then subtracting out the probability of 4 and an even to take out that overlap. So when we're done, we get a value of 1 plus 3 is 4, subtract 1, and we get 3 out of 6 chance, or 1 out of 2 chance of rolling a 4 or an even. All right, now let's head to a deck of cards. We have a Venn diagram here, and our probability of the first event is your hearts. Second event is your kings. And you have one overlap, the king of hearts. So we want to find out what is the probability of being a king or a heart. King or a heart. So we're going to use the formula. So I have a little picture here of what we're removing, the probability of the heart. You have 13 hearts in the deck out of 52. And then the kings, probability of a king, you have 4 out of 52. The probability of the king of hearts, king and a heart, 1 out of 52. So if we head back up to our equation, we're going to take probability of A, which is getting a heart, plus the probability of B, getting the king, and subtracting out the overlap, the king of hearts, 1 out of 52. We go ahead and simplify that. 13 plus 4 is 17 minus 1. 16 out of 52 chance of getting a king or a heart, which reduces to 4/13.